Here's where people think we all came from. And this is in Central Africa. And the migration patterns went from there up through Europe, over to the Middle East, down here into Australia, up through what's now known as Russia and Siberia, and through there over to what's now the United States, and then down to South America. And apparently back when all of this was going on, a lot of these land masses were a lot closer together. And this, of course, this process took many, many years, thousands and thousands of years to occur, but it is interesting to think that it all started right here. Let me just talk a little bit now about how these mutations can cause disease. It's thought that all of us probably have at least 4 or 5 genetic changes that have the potential to lead to disease. And that sort of correlates with the fact that there are about 4 or 5 major classes of common diseases. Heart disease, for instance, cancer, arthritic sorts of diseases, kidney diseases, lung diseases. There aren't that many big clusters of diseases, and they probably correlate with these 4 or 5 major genetic changes. The other important thing to remember is genes come in pairs because we inherit chromosomes from 2 parents, 2 chromosome 1s, 2 chromosome 2s, and so on. And so we always have a backup gene on the other chromosome. And that's why having a mistake in one gene is usually insignificant because you have the other copy to correct for it. But sometimes over a lifetime, these genetic changes can knock out the other gene that was still working. And that's where we think disease occurs. And that's why the bulk of disease in our population occurs in older ages, because it takes that many years for these mistakes to add up. There is another group of diseases called hereditary diseases. Only about 5 to 10% of diseases fit into this category. But in this case, at the very moment of birth, already there's a mutation, because the mutation was inherited from the parent, and it's in the offspring. And so already at the very moment of birth, one of the gene pairs is abnormal or not functioning properly, and all you need then is for the second one to be knocked out or altered. And in these hereditary conditions, what we find is that the disease occurs much younger in life. And that makes sense when you think about, you don't need to knock out 2 genes, you only need to knock out 1, so it doesn't take as long for that to happen. But keep in mind that even in those cases, even when you inherit an abnormal gene, that is not enough, usually, to result in disease. The genetic factor is just one component, and this is reassuring because this is what gives us some control even over an inherited genetic predisposition. Interacting with that are environmental factors, things that we're exposed to that may push this mutation over the edge, so to speak, or even protect us from it. There may be some good environmental factors that are protective. Lifestyle factors, how we take care of our bodies can help either protect us from a genetic risk or, again, push us over the edge. And then, as I mentioned, just the process of aging. Our cells, as we get older, tend to have more defects or mistakes in them just from the aging process. I don't think we know enough about this, exactly why aging should correlate with disease, but there are people trying to figure that out as well. And so if you look at the family patterns, you might be able to detect in your family where are the genes most likely to be altered or mutated. And here's the questions you ask. Are there the same or similar types of diseases from one generation to the next? Does more than one family member in your family have the same type of disease? Is it running in the family, in other words? And is it occurring earlier than usual? This also is kind of a red flag. Here's some examples. People who have polyps in the colon are more likely to go, in multiple family members, are more likely to go on to have colon cancer. People where you see 2 or 3 or 4 people in the family all battling high cholesterol levels, these people are more at risk of heart disease. When you see more than one person with high sugar levels, they're going to be at more risk for going on to get some type of diabetes. Here's just some examples of where you can get more information for yourself about your family when you're trying to search out these things. This is something we often overlook, but there are very good records if you've ever been in the military service. If any of you have ever been in the military service, you know that they're very careful about your health because they've invested so much money in you. They want to keep you healthy and functioning. So military records, if you can get a hold of those, may be a very good source of any early warning signs of, say, high sugar levels or high cholesterol levels. School records might have some clues. Sometimes when we're trying to research our grandparents' generation, our great aunts and uncles, we may have to go to things like death certificates. Sometimes we can request medical records of our parents or other people in our family that are no longer able to give us that information. And then also genealogy records, which you're going to hear more about. So I just try to put this in the context of how does this fit within our whole context of our family story, because I don't think we should just focus on genes and disease. But the history of our family tells us about our own nuclear family, our extended family, our ancestors. It tells us something about the culture that determines how we behave and how we take care of ourselves and our bodies, our spirits, and ultimately, hopefully, these things will all play into our health. Now, just to show you the nomenclature of a family pedigree, and upstairs on one of the tables, there's some copies of pedigrees that you can take home with you and fill them in. Everybody uses these standard symbols: circle for women, square for men. This horizontal line indicates marriage, the vertical line indicates children. This is a horizontal line of two sisters and a brother. The brother's symbol is shaded in because that indicates disease. So whatever disease you're interested in, you would shade in any individual in the family that has that disease. And this line here indicates that that person is deceased